So thanks for coming. Anyway, Igor, Matlin, Checkmarks. I run the solutions architecture group for Checkmarks. Checkmarks obviously is a static application security testing vendor. And so we're going to talk about DevOps today, and we're going to see where security fits in a DevOps. All right, so everybody here is DevOps, familiar with DevOps? Yeah, things? Okay, we'll skip a couple things, but so yeah, what's DevOps about, right? It's a obviously combination of development and operations, right? So the term's been around since 2008, kind of came out of the agile movement, and essentially involves merging software development and software operations. Prior to that, some of us remember that operations IT folks were completely separate from development folks, right? Didn't really much talk to each other, and therefore they had different objectives. Right? The ops people were all about maintaining the 5 nines uptime, and developer folks, especially since the introduction of mobile agile development, were all about getting updates out there quicker, conflicting goals, and conflicts as a result. Right? So DevOps was designed to fix the conflicts and kind of get everybody to work together towards the common goal. Right? So since we're talking about putting security into DevOps, let's talk about some of the technologies that comprise application security testing. Right? SAST, static application security testing, checking application without executing it, running it, source code, analyzing it. Who's familiar with SAST? Me. Dynamic application security testing, running the application, trying to break it, sort of a automated pen testing. A relatively new entrant to the market is the interactive application security testing. Sort of a combination of both. There's an agent running with the app while the app is being executed either through manual testing, integration testing, or by DAST, actually. Runtime application self-protection. Again, the agent, typically as part of the runtime, looking at the application, sometimes not just generating reports back to development, but actively protecting the app, returning errors, exceptions, etc. Web application firewall, a perimeter fence around the app, looking at HTTP requests coming in, or there were some other request API requests coming in, making sure that these requests don't match known attacks. And final, but last but not least, is a software composition analysis. Some folks, like my employer, like to call it open source analysis. So you'll see references to both in the application, making sure that your components don't have known vulnerabilities. Anybody heard of Equifax? No? That's important, right? Oh, guess what? Out there in the whatever area where vendors are, what do you call it? Anyway, you're going to find vendors for all of these technologies. It's interesting, isn't it? I guess these must be important for AppSec. But who can name some of the vendors? So obviously, Checkmarks isn't SAST. But what about DAST? Anybody? AppScan, but they're not here. Rapid7 is here. And AppSpider. IAST. Contrast. RASP. RASP actually bailed on the second day. They were here yesterday with a very nice drink chit sponsored promotion. Anyway, I actually looked at the list and I looked at the vendors around the room. It was kind of cool. So what are the building blocks of DevOps? Right, you have development, you have continuous integration, meaning we check code in, we always build it, make sure that your master branch is always ready to go. Right? No bad code in there, not buildable code. We have continuous delivery, making sure your application can be packaged and again, ready to be deployed. Now, CD can also refer to continuous delivery, which is a step up from continuous deployment, which is a step up from continuous delivery. Deployment means we build it, automatically put it out in production. Kind of scary. Who does that? Who does continuous deployment? No? I would be scared, to be honest. But people do that. And in fact, people go even beyond that, right? It's, I'm old school. I grew up as a developer, right? And I kind of stopped development, crossed over to the dark side about 12 years ago. Back then, we didn't do much continuous things. It was also mostly waterfall. Okay, and of course production, right? You deploy, you run, your folks from your prod team take care of the application while in production, support it. So we just talked about the difference between two CDs, right? CD versus CD. So where does security fit in all of this? Starting from the left, and we all like to start from the left. Development is, development works with source code. So static application security testing is the natural fit here, right? Once we move into CI, and we moved into automated builds, things like quick incremental SAST, or static analysis, come into play. Open source analysis comes into play. As you build, as you run your NPM, it pulls in modules. Your Maven pulls in components. Open source analysis or software composition analysis becomes key. It's the right time to check that. When the application is done, work with IAST and DAST and things that work with running app. And of course, in production, it's WAF and RASP. So we, as vendors, right, AST vendors, have customers who do all sorts of different things. So I want to get a feeling for the audience. Which of these do you do? Who wants to volunteer there? WAF. That's it? And DAST. Okay, well that's, I think is a more traditional way, right? You do your pen test of DAST, and then you try to protect it with your WAF. And we can talk about why that's a good start, but typically not enough, right? As the development kind of cycle accelerates, you want to take care of development security vulnerabilities earlier, right? In fact, sort of evolution of development, right? Not really DevOps, but development in general, and DevOps, is to go from waterfall to agile to kind of lean development, or as a special case of agile, CI/CD, deployment, and operations. Now, continuous operations is scary. Continuous operations means every small code change automatically pushed into production with no downtime, right? I haven't personally seen anybody do that. Have you? I've only read about it. Like I understand that if your application is deployed on Amazon Lambda, right? Then you can switch out little tiny things, and you can work with continuous operations. But I haven't seen it done. However, the theme here is that things become faster and faster and faster. Right? Faster turnaround on features, faster updates. Don't wait for software to be perfect. Kind of push it out. Let the users sort it out. And as we move into more frequent updates, any disruption to this cycle becomes very costly. Right? When your business users expect updates to happen every day, maybe several times per day, any delay is a problem for them. It's a problem for you. So here's the slide that if you actually are to take pictures of my slides, they're going to be uploaded on the website. But if you are to take away one thing from the talk, is that the further your project is on the Devops scale we looked at before, good timing, taking pictures, by the way. This is the slide. This is the slide. Right? The earlier you should start security testing, shift left. And the idea here is kind of the same as with quality control, right? QA. We used to have a QA team, right? There isn't a QA team that sits in a separate corner of the office anymore, right? QA is integrated with development. We all expect developers to run unit tests, create software that doesn't fail tests. Why? Well, again, waiting for later stages to do your development is disruptive to this ever faster cycle of updates. So same principles actually should apply to security, right? When you do a test at the end of the development cycle, it's great. You can find your vulnerabilities, but that happens too late. If you shift your testing left, you're much better integrated with agile and fast development cycle. It is also much easier to fix security vulnerabilities before software is complete. Now, with quality, actually, if you find, I don't know, null pointer dereference in your final testing, right before deployment, I mean, what happens, right? You insert a check usually, and you can mitigate it pretty quickly. But if you find something like SQL injection, then you need to rework your app to do to use parameterized queries instead of just regular SQL. That's not a 5-minute project. That's not an easy task. That potentially can lead to substantial changes to the software. And obviously, the more you change your app, the more of your test cycle you have to rerun. So think of it as, in that way. Security, since security vulnerabilities can frequently lead to bigger changes to the software, you want to find out about them earlier in the cycle. Okay, so from the developer standpoint, what does that mean to our developers? And developers this is a day in the life of a developer, right? You check the code out, you work with whatever it is that USCM, Git, Perforce, CFS. You write your code, you change your code in your IDE, compile, test, run some checks, and then commit it back. Right? And once you commit it, it gets picked up by your CI process. More checks, more compilation, etc. So where would we introduce security checks? Right? There isn't a security check here. Now, security checks, again, different technologies, remember, have different places in the security lifecycle. So for things that happen on the left, incremental and fast static analysis is the key, because you can do that without having to redo your app. Right? And of course, the later you go, the other technologies also become relevant. Now, what happens after you check the code in? Your automated build kicks in. And if you check something in that has bugs or fails tests, the internet is full of memes that deal with broken builds, right? Who has never broken a build in their life as a developer? Right? We're all guilty, and it's not a good feeling, right? It affects everybody. God forbid you do it on a Friday afternoon, right? And it seems to happen on a Friday afternoon, then all sorts of red lights go off and emails come out. So bad things happen when you break the build. And so for developers, like if you have medium-sized team, 365 developers, and each build breaks only a single build once a year, which is not a whole lot, but you have essentially a broken build every day. It's very difficult to maintain this agile development process when your builds are broken every day. So you need to give developers ability to check their work before they check it in. And that's also always been a problem with application security. Why? Speed and accuracy have been an issue with application security tools. If you have a large application, monolithic application, running static analysis on it takes hours, right? Maybe days if it's a large app. Clearly not a good fit. If you use a software as a service solution for application security, sending code off somewhere to be checked before you check it into your SCM, that's not a good solution either. Accuracy has been a problem. False positives, right? They happen. Sometimes they happen quite a bit. And of course, if you break a build, that's bad. If you break a build and it's a false positive, that's even worse, because there was no reason to break a build. So the key is to pick the right solution for you that addresses these two concerns, speed and accuracy. Otherwise, there's no shifting left. Otherwise, you're stuck doing your analysis at the end of the cycle. I'm not here to promote any particular tool, but I do encourage you to evaluate your application security vendors for those two key components, speed and accuracy. And after you're done with your analysis, right, and you have your results, what do you do with the results? DevOps is not just about tools, not just about people. It's also about processes and policies, right? So some of the examples, right? And again, what works for you is something that you'll have to decide, and maybe you guys can volunteer some of your experiences. But in a very common policy is to break builds for new vulnerabilities only. So you run a scan, you have your backlog of vulnerabilities that you maybe don't have to fix right away, and you say that from today, any new vulnerability is going to break build. Most AppSec vendors will let you kind of mark things as backlog, and if they don't use them. But yeah, most actually have that functionality. That's okay. Why? New vulnerabilities are more important to fix because you've already lived with the old ones, right? They are in the backlog. You supposedly look through them. There's nothing glaring. Address the new ones. There are not going to be that many of them. The developers can easily fix what's new. You can dedicate a sprint for drawing down on the backlog. Actually, that seems to work well for teams that, let's say, do security training, and then after that, dedicate a sprint, 2-week sprint on drawing down on backlog. Have you done it with quality issues? You have or some other backlog issues? Same idea. You can add security tasks to regular sprints. Like, let's address, I don't know, cross-site scripting in the next 2 sprints. Right? We have a list of, I don't know, 5, 6, 10, whatever it is. One of the tasks for a sprint is to get, again, works well after you've done some training. Let's have you have a, let's say, team member give a presentation on cross-site scripting. You develop a policy for dealing with cross-site scripting in your application. And over the next sprint or 2, you work on those issues. Why does it work well right after training? We'll talk about it on the next slide. But the key thing to remember is that policies shouldn't be rigid. They should be evolving. When you start application security testing, especially application security testing on code level, there's usually a lot of information for a development team to process. So one of the things one of the ways to deal with it is to limit your scan to maybe only certain vulnerabilities. You can expand that list later as your team matures. So policies have to evolve. Policies have to evolve with new threats. So remote code execution, it's sort of always been a vulnerability, right? But thanks to Apache, it's actually in the news over the last couple years. Made it all the way to OWASP top 10. Let's assume that RC2, 2017 RC2 will pass as is. Remote code execution is going to be there. So threats evolve. Your policy should evolve as well. Different vulnerabilities, right? Old versus new, have different impact on your security of your application. So, what do you think? Is the new vulnerability more critical, or is the old vulnerability more critical? Both, one over the other. Actually, when it comes to vulnerabilities in your own source code, there might not be a big difference. The only choice is when to fix one versus the other. But when it comes to open source component vulnerabilities, older vulnerabilities are always more critical than new vulnerabilities. If vulnerability is on the market, if the CVE is more than 90 days old, you bet there's going to be dozens and dozens of exploits that are really easy to run. And so the older your open source vulnerability is, the more critical it is to fix it. Actually, also needs to be a policy for a development team. So, and I kind of like this slide too, but might be difficult to read small font from the back, but call it the code familiarity, ROI. And it's, another reason why you want to run your tests earlier. Task switching is expensive, right? For developers, it's expensive. You concentrate on something, you are in it, your mind is in it, you remember what you wrote, right? And after you switch to a different feature, that quickly fades in your mind, right? So I don't know if it's really that bad, but certainly, it's not unusual to have to find a vulnerability in code that was written by somebody who left, and no longer with the company. It takes twice as long to fix those, right? I don't know, 3 times as long to fix those. So, now remember this slide? Day in the life of a developer. The best place to start scanning is inside their IDE. Several solutions on the market to do that, right? They address speed and accuracy, 2 things that we discussed. They do analysis either using information that was collected, let's say, overnight during your nightly builds, or they do very quick analysis right inside the IDE, sort of a spell check type of functionality. It doesn't replace your full-blown analysis, but it's a good start. You can run incremental scans on, again, using some of the tools. That gives you benefit of full, deep analysis and speed. And finally, right, a couple of takeaways. Security policy, right, that fits with your DevOps environment is key, right? We talked about some examples. Do some modeling on your app. Figure out what works, what's important for your app. Design security policy around it. Shift security left. The earlier you know about vulnerabilities, the better. Easier and less expensive it is to fix. There's quite a bit of older data on the ROI of fixing vulnerabilities earlier. I haven't seen figures that are more up to date, unfortunately. Would be very interesting to understand how that has changed with the introduction of microservices, for example, right? And newer languages, newer technologies, newer frameworks. Unfortunately, the data is that most of the industry uses is pretty old, but in some cases, the cost to fix a vulnerability after the application is released to production is about 80 times more than inside the IDE. And of course, don't forget about open source components. It's really important, really easy to forget to cover them with a security policy. We tend to concentrate on our own coding standards. Hey, don't do this, don't do that in your own code. But when we bring other people's code in, in the end, it's your application, right? Ask Equifax if anybody's mad at Apache. No, everybody's mad at Equifax, right? So we had a fireside chat yesterday with folks from Previty, and so there was a discussion about how far are you expected to go, how deep are you expected to research things that you bring in. Well, that again is an interesting question. I don't think it was answered before we left. I had to leave fireside chat early. But in the end, it is on you to make sure that the components are safe and secure. So my talk was going to be 30 minutes. I think we're at about 30 minutes, leaving maybe 10 minutes for Q&A, or anybody wants to share their experience with any of the technologies, or adding security into DevOps environment.
I have a question.
Sure.
You talked about the importance of policies being not set in stone, but living things. The organization that I work for, we have a horrible problem with the policies that we put in place. It basically depends on if you're finding new or it's in pre-existing code, and then everything feeds off of that. Do you have like any examples, or should it be on like a finding by finding basis? Like cross-site scripting has X policy that where you get to address it in such and such days, or like application criticality gets X amount of time versus like a less critical. Do you have any examples of those?
So I think we typically start with threat modeling for the app, and criticality of the app is what drives relative importance of different vulnerabilities, right? Your consumer-facing apps, right? Your web apps obviously have much higher much higher emphasis on things that can give unauthorized access to data, for example. Right? But when it comes to existing code versus new code, to me, the criticality shouldn't be affected by that. Your timeline to fix may be affected by that, right? A new vulnerability in new code maybe need to be fixed right away, but they're equally as critical, right? And so when deciding what to put in a backlog, so what I recommend usually, and again, AppSec is different in different organizations, so what I usually recommend is that for vulnerabilities in existing code, for legacy vulnerabilities, do address the most critical ones based on threat modeling for this app. You maybe address cross-site scripting. Maybe only leave some, I don't know, heap inspection vulnerabilities that are difficult to exploit. Could be potentially bad, but difficult to exploit for later. But again, criticality is not necessarily affected. Deploy WAF to address those. I mean, that's protecting from your existing vulnerabilities doesn't have to happen in code. It can happen in production. But I think the threat modeling comes first. And that seems to work well for our customers anyway. Typically, you have a lot more vulnerabilities in existing code than new, and smaller chunks of work are easier to do. Well, thanks for coming, guys. I appreciate it. It's actually a last-minute substitution. I didn't even know what was expected, what was supposed to be here. I got this talk invite last week, but I appreciate you showing up. We are out there if you're interested in talking privately or coming over. I'll turn the microphone off. Your secret's gonna be safe with me. All right. Thank you.